Hello students, so welcome back to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So as you all know, we have started the PYQ series and today we are going to discuss the top 30 most important questions from the chapter Alcohols, Phenols and Ethers. So these questions have been compiled from the last 10 years of PYQs, that is from 2014 to 2024. So by seeing these questions, you can easily identify like which are the high weightage topics from this particular chapter, which are the things that you need to revise, you need to focus more. Okay, so we'll start with this. One more request, please join our WhatsApp channel. The link of the WhatsApp channel is there in the description section of this video. So you can join there so that you can get access to all our class PDFs, you can get access to mock tests, solutions, everything is available. So it will be really beneficial for you. So please do not forget to join the WhatsApp channel. Okay, so now without any further delay, let's get started. While watching this video, please sit with a pen and a notebook and first see the question, write the answer, write your own answer, pause the video, write your own answer and then check the solution. Okay, so that you can know like what is exactly your level of preparation, and whichever questions you are getting wrong, please mark them and understand the explanation. Okay, so fine, let's get started now with the first question here. Okay, so this question is from nomenclature. So there's a reaction given to you, 2014 question. Okay, now what is the speciality about this question is you cannot directly go for nomenclature if you do not know the reactions, you do not know how to find the product of this reaction, right? So this is very important. First you need to identify B and then you need to write its product. But one thing here helpful is if you see okay the options, then you can easily understand that there will be the B will be some alcohol. Okay, so fine, let us now try this question. You can see this question is a very easy question. I'll tell 30 seconds is enough because this is very simple reaction. So now the reaction is between a carbonyl compound and a Grignard reagent. Right, now in Grignard reagent we know we have plus and minus. Okay, and here also we have O minus and carbon is plus, so this one can attack here and this bond will shift here. Okay, and O minus will take this MgX and this carbon will take this R group. Okay, so now let us see here what we have. We have got here CH3, CH3, then we have CO, and to this O we have MgBr. Okay, and then what I have on this other side, I have H, right? And then I have attacked this CH3. So this is the CH3 that is attached from the Grignard reagent. Okay, I think this is clear. I have written these compound, this one, and then to this carbon this CH3 is attached and OMgBr. Now after, this is your A. Now after hydrolysis what will happen, this OMgBr will be converted to OH. Okay, so now this is the final product that we have got. Now if I see the structure, let me draw it little simpler forms. I'll get CH3, CCH3. Okay, then I have C and I have OH on this carbon and I have CH3 on this carbon. Right, this is what I'll be getting. So if I want to name it, so 1, 2, 3, 4. So you should get least priority to the functional group. So I'll get obviously butane. So that's why these three can be answered. This is not the correct answer. And butane 2-OL should be there. So this is 3-OL, means this is also wrong. So out of these three, we have 1, 2, 3. 3-methyl butane 2-OL. Okay, so 3-methyl butane 2-OL. Option number A will be the correct answer. Okay. Next question, when a tertiary alcohol A, C4H10O reacts with 20% of H3O4 at 358 Kelvin, it gives a compound B, C4H8, okay, as a major product. The IUPAC name of the compound B is, so you can see this question was asked in 2024, this year question. Okay, so this is also very simple questions, 30 seconds is enough, easy question. So what we see that H3PO4, you should know what is H3PO4. It is a dehydrating agent. Okay, and dehydrating agent means it reacts with alcohols. Okay, and you can see the formula here. What is there? This is C4H10O and this is C4H8. That means 2 hydrogens and 1 oxygen is removed. That is, dehydration has taken place, right? So now we need to again find the IUPAC name. Direct question is not there. For this you definitely need to know the reaction. And here also Sage-Zeff rule is to be utilized. Now if you see, first we have C4H10O. So we have 2 possibilities for this one, right? You can have this one, butane 1-OL, or you can have butane 2-OL. Okay. Now if we need to find the major product, right? Okay, now one more hint is also given. We have a tertiary alcohol, right? So tertiary alcohol means there is only one possibility. So we have like this. This is the tertiary alcohol, right? Now we can have H here. So there will be dehydration, this part will be removed, and I will get like this some structure, okay? H you can balance. So if I 1, 2 and 3, so I'll get 2-methyl propene, right? So 2-methyl propene, correct answer will be option number D, okay? Here I missed, this is a tertiary alcohol, okay? Next, question number 3 is about physical properties, which is the most viscous. So you should know about the physical properties of this one. This is also very easy question. You should know the structure of the options, okay? So now if you know ethylene glycol, glycerol, methanol, ethanol, okay? So glycerol is a compound which is having 3 hydrogen groups, like 3 OH groups is present, like this, okay? This is glycerol. So now because of these 3 OH groups, it will be more involved in hydrogen bonding, so more intermolecular forces, viscosity will be highest here. So correct answer will be option number B here, okay? Next, again questions are from your chemical properties. 2024 question, PCC is. So this is a damn easy question. If you know the very commonly well known reagent, we generally use it PCC or PDC to convert alcohols, right? So alcohols to aldehydes, right? This is a mild oxidizing agent, okay? So super easy question, I can say. 30 seconds is very easily you can solve it. Where you can do mistakes, if you are not very sure, there may be the options are very like I can say similar options are there, so might be a little confusion, but students who are very clear, they can definitely do it. So that is a mixture of chromium trioxide, okay, with pyridine plus HCl. That is option number D here, okay? Next, coming to, one second, okay, next coming to question number 5, okay, this is also very important question. This question was again asked in 2024, chemical reactions. I will mark this as a difficult question. You can take easily 1 to 2 minutes to solve this question. 8.8 gram of monohydric alcohol, okay, I am underlining the key words here, is added to ethyl magnesium bromide in ether and liberates 2240 centimeter cube of ethane at STP. This monohydric alcohol, when oxidized using PCC, forms a carbonyl compound that answers silver mirror test. The monohydric alcohol is. Okay, very important question here, and clues are hidden inside the question. You need to search the clues very cleverly, okay? So first of all, we know that it is a monohydric alcohol, means there is only one OH group present in the whole compound, okay? Now the second part is, when this monohydric alcohol, when oxidized using PCC, forms a carbonyl compound that answers silver mirror test. That means when, suppose this is your monohydric alcohol, when you treated it with PCC, it gives a compound Y which answers silver mirror test, means Tollens reagent, right? Silver mirror test, okay? So now you should be very clever to know here that this Y must be one aldehyde, okay? Y must be aldehyde. If Y has to be aldehyde, because aldehydes give a positive test for Tollens reagent or can give positive silver mirror test. If Y is an aldehyde, then X must be primary alcohol, right? Because if X is secondary alcohol, will get ketone here, and ketone does not give silver mirror test. So X has to be primary alcohol. Now let us see the options here. Butane 2-OL, we have like this. This is butane 2-OL. Next we have 2,2-dimethyl propane 1-OL. So I have 2,2-dimethyl propane 1-OL. Then pentane 2-OL. Okay, this is pentane 2-OL. And next I have 2,2-dimethyl ethane 1-OL. So I have next one 2,2-dimethyl. Okay, it's like this, I think. 2,2-dimethyl ethane 1-OL. Okay, actually this name is incorrect. Okay, because we have, it should be 2-methyl propane 1-OL, the correct IUPAC name, but fine, this structure is given to us. Okay, 1, 2, 3, 4, 5, 1, 2, 3, 4, 2,2-dimethyl ethane 1-OL. Okay, fine. So now if you see here, this is a secondary alcohol and this is a secondary alcohol, right? So definitely these two cannot be the answers. Okay, so we need to either find out these two options, B and D. I am very sure it should be B, because D is also an incorrect option. The IUPAC nomenclature is wrong here, but still we'll find out the B. Okay, so I'll erase this one first and we'll see what information we can gather about to find the structure of this alcohol. Okay, so now it is telling that when monohydric alcohol is, so when you treat any ROH, okay, with RMGBr, okay, we get RH. Okay, this is what you should first know, the reaction about alcohols with Grignard reagent. Okay, methyl magnesium iodide in dry ether gives ethane at STP. Okay, so that means this is what, this is ethane. Okay, so now the question is telling if this ether is produced. Okay, so now how will be the ethanol will be produced? Now see, what is the reaction exactly, we'll write first. Okay, so let us take one example here. Suppose you have any alcohol CH3 CH2OH, okay, and you have CH3 MgBr. Okay, first understand the reaction. So what happens, this one will give you H plus, okay, this is plus, this is minus. Okay, so this minus takes this H. Okay, so what will I get? CH3 CH2 OMgBr, okay, plus this one will give me CH3 and then one H CH4. So this byproduct is the one which is talking about in the question. So now, so I have this one, so I'll write like this. See, this is one example I gave you. Now if I solve according to the question, see, you have one one monohydric alcohol which we need to find out, and it is reacting with what? Ethyl magnesium bromide, that is C2H5MgI, right? Ethyl magnesium iodide in ether. So what will happen? This H will come here, so I'll get ROMgI plus C2H6. Okay, this is the ethane group. Now here what I can say, this is 2240 centimeter cube. Okay, so now what does this tell me? 2240 centimeter cube, I can convert it into number of moles because it is at STP. So what is the number of moles of ethane? Given volume by molar volume. So 2240 by 22,400, that is the STP volume. If you divide, I'll get 0.1 mole. Right? So what can I say? That this one must be 0.1 mole. Okay, if this is 1 mole, 0.1 mole, then see 1 mole of this one reacts with 1 mole of this one to give you 1 mole of this one. Now if this is 0.1, then definitely this monohydric alcohol is also 0.1 mole, right? Okay, if this is 0.1 mole, now we can find the mass of this alcohol, because molar we have to find the molar mass of the alcohol. So we know number of moles is what? Given mass by molar mass. Okay, so I just need to calculate the molar mass. So I will divide this one, 8.8 divided by 0.1, that is 88 grams per mole. Okay, so if I need to check the mass of these two options, whichever is having 88 gram per mole, that will be the correct answer. Now if you see here, okay, I have the formula like this here. Okay, so we have 1, 2, 3, 4, 5 carbon, 1, 2, 3, 4, 5. So 12 5s I have 60. Okay, then if you see hydrogen, 3, 3, 3. So there are 9 hydrogens, 10, 11, 12. Okay, then I have oxygen 16. So if I add this one, I'll get 88 grams per mole. So the correct answer for this question will be option number B. Okay, fine. Next question number 9. A better reagent to oxidize primary alcohols into aldehydes, 2023 question. Super easy question, you should know this is a mild oxidizing agent. PCC is the correct answer, option number A. Okay. Next question number 7. Compounds P and R in the following reactions are. So you have to find the products here. Okay, so based on chemical properties, this is a reaction, but the reaction is very easy. The confusion may arise in this B2H6. You should not forget what is the role of B2H6. So I'll repeat here what is the role of B2H6 or hydroboration oxidation. What does it do? It adds H and OH following anti-Markovnikov's rule. Okay, that should be clear in your mind. So okay, now let us first find the products, then we'll discuss. First, CH3, CHO and CH3 MgBr H3O plus. The Grignard reagent will happen. So what I'll get? CH3 COH, okay, CH, then I have CH3. Okay, now this is P. Now if there is concentrated H2SO4, what will happen? There will be I can say double bond, dehydration will take place. So Q will give me CH3 CH double bond CH2. Okay, this one will be there. Now R will be B2H6. Okay, if you treat B2H6, here OH will come, anti-Markovnikov's rule. So I'll get R value, I'll write on this side. Okay, 1 second. Okay, so here if I take R will be CH3 CH2 CH2 OH. Okay, so now if you see here OH is present on the second carbon and here OH is present on the first carbon, right? So these two are what? Positional isomers. So the correct answer for this question will be option number A, that is positional isomers. Okay, now let us see the next question. Question number was again asked in 2023. So reaction with HX, this is a super important topic, very important topic. You should know how the bond will cleave. Okay, so the heating of phenyl methyl ether with HI produces an aromatic compound A, which on treatment with concentrated HNO3 gives B. A and B respectively are. So very tricky question. You should know the reactions of ethers as well as reactions of phenol to solve this question correctly. Okay, so now if you see, we have phenyl methyl ether, right? So that means this is phenyl, then we have methyl and ether. So whenever there is a phenyl group, no doubt the bond has to break here. So I'll get one product as phenol, okay, which is nothing but your A. Okay, now A on treatment with concentrated nitric acid. A on treatment with concentrated nitric acid. So you know concentrated nitric acid, OH is a highly activating group. All the three positions will be substituted. So what will be the product I'll be getting? I'll be getting here, that is your picric acid, right? So here I'll have OH, but here I have NO2 group, here I have NO2 group, okay, and here also I have NO2 group. Okay, so we'll get phenol and picric acid. Option number D will be the correct answer. Next, question number 9. So again, this is a reaction based question. Question was asked in the year 2023. Again, this is a moderate level questions if you have remembered the phenol, because when you see so many steps have been involved in this question, then it becomes little tricky. So first one is NaOH. So if NaOH is there, we will get sodium phenoxide ion O minus and Na plus, right? That is your A. Next, what happens? Next we have CO2. So in the presence of CO2, what will I get? We will get O minus, Na plus and COOH. Okay. Next what happens? Next we have this anhydride group. So this one will be converted to, we will get OCOCH3 and COOH. Okay, so this compound is nothing but your aspirin, or the chemical formula of the compound aspirin. This reaction is there in NCERT. It is asked in the PU boards many times, so definitely a important question. Next, question number 10. an organic compound with molecular formula C7H8O dissolves in NaOH and gives a characteristic color with FeCl3. On treatment with bromine, it gives a tribromo derivative C7H5OBr3. The compound is. Question was asked in 2022. Moderate question and tricky question, but yes, if the concepts are clear, there should not be any error. So first of all, it is telling C7H8O. So remember, whenever there is more than one carbon, then more than 6 carbons, then definitely you can think of a benzene ring. Okay. Now, it is a characteristic color with FeCl3, so that symbolizes that it is a phenol group. Okay. So now I can have phenol group definitely. Okay. But one more carbon is there, right? C7. So there must be one CH3 group we can easily identify. But now this position of CH3 can be at 3 different places: ortho, para and meta position. Okay. We'll get ortho, meta and para positions. Okay. Now what happens? On treatment with bromine, it gives a tribromo derivative. Tribromo derivative means when you treat with this one, tribromo derivative will come at only ortho and para position because OH is a electron donating group, right? So we need tribromo derivatives on these 3 positions. That means methyl group cannot be here, methyl group cannot be here. Methyl group has to be present here, so this will be the correct answer, and this is nothing but your metacresol, that is option number A. Okay, fine. Next question. Question number 11. Among the following, the products formed by the reaction of anisole with HIR. 2022 question. Reaction with HX, cleavage of bond questions. You need anisole. So we have like this O and CH3. So whenever this O group is there, the bond has to break here. So we will get here phenol, okay, and HI, right? So here it will be I. So we will get CH3I. Okay, so phenol and iodomethane, option number C is the correct answer. Next question number 12. In Kolb's reaction, the substances are, so this is 2022 question, name reaction, direct question. So we need here sodium phenoxide ion with carbon dioxide to get salicylic acid. Option number C is the correct answer. I don't think any doubt should be there in this question because directly name reaction is asked. Next question number 13. A compound A, C7H8O, is insoluble in NaHCO3 solution but dissolves in NaOH and gives a characteristic color with neutral FeCl3 solution. So this automatically tells you that characteristic color with FeCl3 means it has to be a phenol group. Okay. When treatment with bromine water, A forms the compound B with the formula C7H5OBr3. A is, so 2021 the same question was asked, like just now we discussed, right? So which question was this? In 2022 also the same question was asked, but options were little different. Just now as we discussed, this is also moderate and tricky question. You should be very careful here. As I told you, the 3 ortho, para and ortho, 2 ortho positions and 1 para position should be free. So we need ortho and para positions free. Here this cannot be there, this cannot be there. It has to be metacresol. Option number B will be the correct answer. Already discussed the all concepts. You can watch it again. Now, okay, this question was again asked in 2021. Okay, the same question was repeated. 1 second. Let me check once. 1 second. We had, okay, the same question is asked in 2021 as well. The exact questions are copied. You can see the same question. We'll solve it again for you. So this is chemical reaction. 30 seconds is more than enough. Repeated questions you can see. So we have CH3COH and we will get CH3, okay, and then CH3 here. Okay. So if you do dehydration, double bond will come here. So 1 second, I have written this product wrong. We have like CH3, C, OH, H and CH3. Okay. Now there will be dehydration, we'll get a double bond here, then OH will come here, right? So the final product, these two are what? Positional isomers. So correct answer here will be option number B, that is positional isomers. Okay. Next, question number 15, the steps involved in the conversion of propane 2,1-OL to propane 1-OL. Okay, easy question, reaction based question. So we have propane 2-OL, okay, and I want to convert it into propane 1-OL. Okay, propane 2-OL to propane 1-OL. Now if you see, first of all, what we can do here is heating with PCl5, heating with alcoholic KOH, acid catalyzed addition of water. So first, if you do heating with PCl5, this OH will get converted to what? Cl, right? This will get Cl. Next, if you do heating with alcoholic KOH, we'll get a double bond. Dehydrohallucination will take place, right? So we will get a double bond here. One second. So we will get a compound like this. We'll get this one. Now if you do acid catalyzed addition of water, that follows Markovnikov rule, and again OH will come here. We won't get propane 1-OL, we'll get propane 2-OL. So that is why we can eliminate option number 1. Okay, so I'll write what was the question. Understood why this is eliminated? Because if you do acid catalyzed, Markovnikov addition will take place. Now heating with PCl5, heating with alcoholic KOH, hydroboration oxidation reaction. Okay, hydroboration oxidation reaction will give you propane 1-OL because it follows anti-Markovnikov's rule. So correct answer can be option number B. Let us see, first we can do directly dehydration, addition of HBr in presence of peroxide, heating with alcoholic KOH. Sorry. So this part is correct up to this one. Okay, if you again heat with alcoholic KOH, the final product will be one alkene. Okay, so this is also incorrect. Next, dehydration, addition of HBr, so that will give you again the same product and you will get propane 2-OL. So option number B will be the correct answer here. Next, which of the following gives an ether as a major product? 2020 question. So chemical reactions or preparations of ether should be very clear. So if you remember Williamson ether synthesis, we have Rx plus R-ONA. Okay, and here you should remember this Rx must be a primary alkyl halide. Okay, so now if you see R, here this alkyl halide is tertiary, so this one will not give you. So whichever options is having R, we can eliminate both them. Now you need to check Q and S and P and Q. That means Q is common, so Q will definitely give you. Out of P and Q, you need to check. So if you see here, C6H5CH2Br, CH3ONA, yes, this one can give. Now here if you see this part, okay, C6H5, CH double bond CH and Cl, right? And you are attacking it with CH3O minus Na plus. Now this one will attack here and this bond should shift, but this Cl is attached to an sp2 carbon and there due to resonance this bond is very strong, right? So it is not possible for CH3ONA to easily attack and remove chlorine. So that is why this one will also not show. So P and Q, that means option number C has to be the correct answer. Okay. Next, question number 17, match with their pKa values. So you should know about the acidic order concept. So here you should remember electron withdrawing group increases the acidity, electron donating group decreases the acidity. This concept should be there. And one more thing, phenol is more acidic than alcohols. Okay, these three concepts you need to revise. So first of all, if we see, picric acid has the 3 NO2 groups. Structure of picric acid, remember, we have OH with 3 NO2 groups, right? So this is what picric acid, more number of electron withdrawing groups are there, definitely acidity will be very high. But here again a catch is there, that acidity, if acidity is more or acidic strength is more, then pKa value will be very less, right? So that means if picric acid is the most acidic compound, its pKa value will be the least one. So out of this one, which is the least one? 0.78. So I can see D should be 2. So you can see which options is having D2, we can eliminate these two options. Next, if you see, there is one electron withdrawing group in para-nitrophenol. There is only one electron withdrawing group. That means what? That after this should be the most acidic. Means its pKa value should be the next least value. So after 0.78 we have 7.1 directly, right? So B should be 4. So out of these two options, B is 4 only in this particular option. So option A will be the correct answer. Okay. Next, if you see, after that phenol should come. So A should be having 10 value. So that is A is 3, and C the least acidic and the highest pKa value, that is 16. Okay. Option number A will be the correct answer. Here what all concepts you need to revise? Electron withdrawing group increases the acidity, electron donating group decreases the acidity, phenol is more acidic than alcohols, and if acidity is more, pKa value is least. Okay. Next question, which of the following can be used to test the acidic nature of ethanol? 2019 question. This reactivity, if you have seen reactions with metal, test the metallic or the acidic nature of the compound. Option number D will be the correct answer here. Okay. Next question, phenol can be distinguished from ethanol by the reagent. Okay. So, okay, this is aromatic alcohol, this is aliphatic alcohol. 2018 question, again easy question, but if you have remembered the phenol reactions properly. Okay. So now reaction with bromine water, if you have remembered it, phenol decolorizes the bromine water, right? Decolorizes bromine water, but ethanol cannot do so. So we can distinguish them by using the bromine water. Okay. Next question, when the vapors of tertiary butyl alcohol are passed through heated copper at 573 Kelvin, the product formed is. This is super easy question, direct reaction based reaction with copper. If you remember, primary alcohol will give you aldehydes, right? Secondary alcohols will give you ketones, and tertiary alcohol will give you alkenes, right? Now if you see, we have a tertiary alcohol, tertiary butyl alcohol, then that definitely it will give you alkene. So we can eliminate this option and this option. Now if I see this one, tertiary alcohol means tertiary butyl alcohol is this one, this is H, dehydration will take place, I'll get a alkene here, I'll get this compound, right? So this is 2-methyl propene, right? So 2-methyl propene, option number C is the correct answer. Next, the product X and Z in the following sequence are. So this reaction I can say moderate based question because a lot of reactions have been involved here. So first of all, if you see X, this is addition Friedel-Crafts alkylation, right? But if you remember, the most stable carbocation is formed here. So this one will be added and we will get a compound like this, C and C. Okay, isopropyl benzene we will get. So we will get isopropyl benzene, the first one, isopropyl benzene phenol. So we can eliminate this option number B and D. Okay. Next, coming to if you add O2. So what will I get next? If I add O2, I will get here O2. Okay. So this is my Y. Now once you get H plus and H2O, we will get here, we'll get a phenol, okay, and acetone, right? Phenol and acetone. So phenol is already given to you. So this is your Z and this is your X. So Z is acetone. So that is here option number A is the correct answer. Okay. Next question, which of the following cannot be used to oxidize primary alcohols to aldehydes? So this is question was asked in 2017. Again, if reagents are clear, then these questions are super easy. 30 seconds is more than enough. So if you have primary alcohols and you want to convert it into aldehydes, then we need mild oxidizing agents. Okay. If you use strong oxidizing agent, what will happen? If I use strong oxidizing agent, then what will happen? I'll get acids, carboxylic acids, right? Now, what are the mild oxidizing agent? We have PCC, we have PDC, we have CrO3, we have copper at 573 Kelvin. Okay, this is not an oxidizing agent, but can be used for this conversion. So you can see CrO3 mild, PCC mild, KMnO4, this is a strong oxidizing agent, KMnO4 and K2Cr2O7. Strong oxidizing agent will convert alcohols to acids. So this cannot be used for alcohols to aldehydes. So option number C will be the correct answer. Okay, very simple question. Next question. The products formed during the following reaction. Again, this is a cleavage of ethers, very important question, very important topic for ether as well. So here you remember we have like this, right, RO R dash. If both the groups or any one of the group is primary or secondary, okay, both the groups or one group is primary, one group is secondary, anything is like this, then it follows SN2 mechanism, and the nucleophile will attack on the less hindered site, okay. But if there is any tertiary group or a stable carbocation, a stable primary or secondary carbocation, in that case it follows SN1 mechanism, and will be checked which carbocation is more stable, and nucleophile will attack on the most stable carbocation. So now if you see here this is a tertiary group, right? So definitely carbocation will be formed here, plus charge will come here, and this I minus has to attack here, right? So what will I get here? This will be the product, and this one will be CH3OH. So correct answer will be option number A, okay. So these all are your wrong options. Fine. Now let us see the next question. In the reaction, in the reaction you have to find the final product Z, okay. 2016 question, again a moderate question because a lot of steps have been involved. First we have ethanol, but these questions are very interesting to solve, and you get a lot of practice while solving these type of questions. Reactions are all refreshed in your mind when you do these type of questions. Alcoholic KOH, what first? PCl5, OH will be replaced with PCl5, right? So I'll get CH3, CH2, Cl. Next we have alcoholic KOH, there will be dehydration, so dehydrohallucination, we will get alkene. Next we have H2SO4, and so that is acid catalyzed water, so that means it will add water following Markovnikov's rule, but since it is a symmetric alkene, doesn't matter, so we came back to the original product, we will get CH3 CH2OH, option number D, okay. Next question number 25, most acidic, you need to find 2016 question, most acidic compound, okay. So if you have most acidic here, again the same concept, you have to know about the electron withdrawing group will increase the acidity, electron donating group will decrease the acidity, right. So if you see here, phenols are more acidic than alcohol, so definitely we can eliminate this one. Now here there is no group, and CH3 is an electron donating group, right. So that is why, and NO2 is an electron withdrawing group, so definitely it will increase the acidity. Option number C will be the most acidic. But if you want to order them, okay, so first will be C, then will be B, then we'll have D, and then we will have A, okay. The order will be like this. Next question number 26, the reaction which involves dichlorocarbene as an electrophile. 2016 question, name reaction, super easy. Reimer-Tiemann reaction involves dichlorocarbene, that is CClCl. Okay, this is the electrophile that is produced in the Reimer-Tiemann reaction. Okay. Next, ethanol is converted to ethoxyethane. You have ethanol, okay, ethanol converted to ethoxyethane, that is ethanol converted to ethoxyethane. How can we do this? Okay, so for this we need Williamson ether synthesis. First I need to convert them to ethoxide ion, okay, then I need a iodide, like, okay. So if I take like this, then this one can attack here and this one can go. So first of all we need ethoxide ion. So by heating excess of ethanol with concentrated H2SO4 at 140 degrees Celsius. Okay, this is one method of Williamson ether synthesis. Another method is your dehydration of alcohols, right, at 413 Kelvin, right. That is this method. By heating the excess of ethanol with concentrated H2SO4 at 140 degrees Celsius is nothing but 413 Kelvin. So correct answer here will be option number A. Okay. Next question number 28 was asked in again 2014. So okay, so this question is like you have to react with OH and C6H5CO, Cl is given as a base, and then you are doing nitration. The major product is, okay. So first of all, we can have that we have here OH, okay, and C6H5COCl, means that will add that will be like one group is present here and one group is present here. So this can be like OH can react with this one and we'll get OCOC6H5, right? So I can get like this, that is OCOC6H5. So I'll write with an erase, I'll write it in the structure in this form. We'll get this one. So how is this reaction happening? C6H5COCl, right? So this is what? Electron donating, electron rich center. This is electron deficient center. It attacks here, this bond comes and this carbon goes. So we'll get this 2 ring first. Now what is there? Now we are doing nitration, right? So nitration will means one of the group will be attached to nitration. One of the carbon, one of the ring will undergo nitration. Now here is the thing that you should be very careful. Now see, this ring, okay, nitration is electrophilic substitution, okay, electrophilic substitution. That means we need that whichever ring is more nucleophilic, okay, whichever ring is electron rich, okay, whichever ring is electron rich, there the nitration will happen or NO2 group will attach there. Now if you see this ring, okay, here how the resonance take place, like this, okay. So now this is what this CO group is removing electrons from the ring, removing electrons from the ring, or I can say making electron deficient. Okay, so nitro group, which is already a electrophile, will it be interested to come here, which is already electron deficient? No, right? But if you see here how the resonance take place, like this, right? This ring is electron rich. So nitro group will be attached at the para position of this particular ring. Okay, so now I can say you can be confused with the options here. Very tricky options are given. So here there is one option number A and option number C. Here though we can eliminate easily because there is no OH in the product and there is no 2 NO2 groups in the product. Okay, so we can eliminate these 2 options very easily. Now if you see here, this is the electron donating ring or the electron rich ring and NO2 group is attached here, and this one is electron withdrawing ring or electron deficient ring and NO2 is attached here. So this will be the correct answer, option number A. Clear? This is a very important question. If you have any doubt, still not understood, please watch it again. Otherwise, comment it, I'll explain. Okay. So let us see the next question now. 0.44 gram of a monohydric alcohol, okay, monohydric alcohol when added to methyl magnesium iodide in ether liberates 112 centimeter cube of methane. When PCC of the same alcohol forms a carbonyl compound that answers silver mirror test, the monohydric alcohol is. This is again very similar question that was asked in 2024. So you can see 2014 question pattern is also repeated 2024. So you need to at least solve 10 to 15 years of last year papers. Okay. So now if you see what exactly is happening, as I told you in that previous question also, this is giving silver mirror test. That means what? The alcohol or the aldehyde is like, suppose there is one alcohol, okay, the question is like this, there is an alcohol. If you oxidize this, we get a carbonyl compound, and carbonyl compound can be either aldehyde or ketone, right? This can be either aldehyde or ketone. Now when this one is done with silver mirror test and it is coming positive, that means what? If this is a positive test, then this has to be aldehyde, because ketones does not give tolerance test. So if this is aldehyde, then this has to be primary alcohol, because primary alcohol on oxidation will give you aldehydes. So definitely I can say now that this monohydric alcohol which is given to you in the question is nothing but a primary alcohol, right? So in that case what I can do, you can see option number A is secondary alcohol, we can eliminate. Option number C we can eliminate. B and D we need to think. Now what is the reaction happening? We have this monohydric alcohol, okay, and then we have methyl magnesium CH3 methyl magnesium iodide, okay. then if these two will react, what will happen? This is O minus, this is H plus, this is minus, this is plus, right? So this Mg will take this one, so I'll get R dash O Mgi, okay, and then I have CH4. Now this methane mass or volume is given to you as 112 centimeter cube, okay. Now if I want to find the number of moles of methane given volume by molar volume, okay, so how much will I get this? 1 by 2 into 10 to the power of minus 2, okay. Now if you see that 1 mole of this one is reacting with 1 mole of this one to give 1 mole of this one. Now if this is 0.05, or I can say 1 by 2 into 10 to the power of minus 2 moles, then definitely this alcohol must also be 1 by 2 into 10 to the power of minus 2 moles, right? Now if this is true, I can say that so I can say now that number of moles of the alcohol is also same, that is 1 by 2 into 10 to the power of minus 2, okay. Now we can easily find the molar mass of this one because we have the given mass of that, right? So I can write that number of moles is equal to given mass by molar mass. So I can write that molar mass is equal to given mass 0.44 by 0.01 into 2. So I'll get how much? 88. So as we have seen already, this molar mass will come out to be 88. So correct answer will be option number B, okay. Next, question number 30 is on acidic strength, which is the increasing order of acidic strength of the following. Question was asked in 2018. Acidic strength is the most common concept that is repeated over and over. Again, you should remember 3 points. Donating group is more like if donating group is present, it will decrease the acidity. Withdrawing group will increase the acidity, and pKa and pKa and Ka are inversely proportional. Now first we should draw the structures correctly. Para-methoxyphenol, you have this one, para-methoxyphenol, okay, this is para-methoxyphenol. Next you have para-methylphenol, okay, we have para-methylphenol. Then we have para-nitrophenol, okay. So now if you see, this is electron withdrawing group, okay, this is donating group, and this is also donating group, okay. Now if it is withdrawing group, its acidity will definitely be highest, so 3 will be highest. So with options you can see there is only one option with 3 highest, so answer has to be option number C definitely. But if you check option number 1 and 2, how to predict, because both are electron donating group. Here you should know that OCH3 donates by plus R effect and CH3 donates by plus I effect, okay, and plus R is more dominant, that means this will donate more. If it donates more, acidity will decrease more, right? So this will be the least acidic, so 1 will be least, then 2 and then 3, so correct answer will be option number C, okay. Now let us see the next question here. Which of the following orders is true regarding the acidic nature of phenol? So first you need to draw the structures, okay. This question was asked in 2017. Easy question, just you need to draw the structures correctly, okay. So we have first is phenol, okay. Then you have orthocresol phenol, okay, and next you have orthonitrophenol. These are the groups that is present. Now here what happens, if you see, nitro is an electron withdrawing group, so definitely its acidic nature will be the highest. So here we have highest as nitro group, and here we have nitro group in the highest. These two options will not be there. Now this is electron donating group, so this will decrease the acidity, so this has to be least one, so orthocresol will be least one, and phenol here, which has no groups attached, it will be in the middle. So option number B will be the correct answer, okay. Fine. Next, if we see question number 32, again you need to arrange them. So a question was asked in 2015, same acidic order question. First is, you can see nitrophenol. Nitro group is electron withdrawing group, definitely its acidic nature will be highest, so 1 will be highest, okay. Next, if you have, so 1 will be highest here, okay, there is no 4, just eliminate these 4, okay. So we have all the options, I can say 1 is highest, okay, fine. So I can write these options right like this, 2, 3 and then 1, and here we have fine, these options are little incorrect, but we'll find the answer, okay. Let us leave these options and find the answers correctly. So next we have metacresol. Cresol means your CH3 group. This is again an electron donating group. So this will decrease the acidity. So I'll get 2 here, and phenol has no group, and then 2, 3 and 1. Okay, this will be the correct answer, that is 2, 3 and 1. So you can, these options you can leave. This will be the answer for this question. Okay. So yes students, these were the top 30 PYQs from the chapter alcohols, phenols and ethers. So you have seen that concepts have been repeatedly asked, right? So the questions are from the reactions of phenol, reactions of alcohols, acidic order. So these are the most important topics that you must revise from this particular chapter. Okay. Next, if you have any doubt in any question, you didn't get any concept, do not forget to comment down. I'll definitely address it. I'll take it in my next video, any question if you're not understanding. So please comment down if you have any doubt. Okay, so thank you for watching, and if you are thinking that our series, our PYQ series, our KCET series is helping you in your preparation, do not forget to subscribe the channel. Thank you for watching. All the best for your KCET preparation, and see you soon in the next class.